All right, let's start on the minutes. It's 10:30 in the meantime. Feel free to still come in and take a seat. We've got plenty of ground to cover though, so let's rather use the hour that we have. All right, this is a session on Spring, as you may have figured from the title. Welcome. I've called it Modern Java Component Design with Spring for the 2. Because it's a very design-oriented session. I'm going to, well, run you through the Spring Component Model, the annotated Spring Component Model, by code examples. So the presentation is almost exclusively code examples on slides, but code examples. And we're going to review the Spring Component Model design from its very fundamentals up to many of the corners of the model. The endpoint model, for example, event listeners, GMS listeners, HTTP endpoints, many of those things as well. So we've got quite some ground to cover, and I'm going to take you on this ride. Even if you have been exposed to Spring before, which I suppose you have, we can actually quickly check who's been using Spring already. All right. That's cool, because that's more or less what I assume here. I hope there's going to be new stuff for each and every one of you in there. I'm going to take a few minutes initially to review a few basics, but maybe there's even something new to learn there. And we're going to spend most of this session on, say, more advanced, slightly advanced topics. But still from a design perspective, so we're not going into many runtime details. We're going to look at it from the design of your source code, right? This is what this presentation focuses on. Another question, actually, while we're at it, I suppose a few of you have been to Josh Long's Bootiful sessions yesterday. Can we quickly show hands? Who's been to Josh Long's sessions yesterday? All right. Those sessions, of course, showed a quite different perspective from the Spring universe. So in this particular session here, it's pretty strongly Spring Framework-centric. Spring Framework as in the core Spring Framework project. Many of the component model elements that we're talking about here ship in the core Spring Framework. But of course, they show up in many parts of the Spring ecosystem. And many of the design conventions and the design reasoning behind this component model shows up across the Spring project portfolio. A few words on myself. I've been doing this for a long time. So I've been managing the core Spring Framework project for about 12 years now. And I've been guiding the Spring Framework from its very inception up to where it is now. So I have been managing also all the revisions of the component model across those 12 years. And with Spring Framework 4 and the ongoing Spring Framework 4.x releases, we are at a pretty comprehensive point in terms of the programming model. So from the perspective of what we meant to achieve in terms of an annotation-based component model, this is pretty much it. We are completing it, refining it in a few corners, but the model is very stable. We're talking about the same model that we've been using for 6, 7, 8 years now, with just new additions in many places, completing the picture. But I hope it comes across as a unified whole to you. So let's start with the very basic component. A component in Spring is just a class. A class in regular source code with a few annotations giving hints to what kind of class this is, right? So let's say just any kind of service implementation in my book admin service here is meta annotated with an add service annotation on top. This is just a formal way of declaring the role of the class. So we're just really saying it's not any kind of class, it's a service class. It has a certain role within your code base, a certain role within your application architecture. Instead of just indicating this through the class name, which also says service, we're formally saying so through the add service annotation. We can, of course, express other characteristics. We have the type level annotations up there, which primarily deal with identifying a component and, well, expressing some characteristics at the component level, for example, if it's supposed to be lazily initialized. The most important part of the component model is to be found at the method level, though. Through specific annotations on constructors or on methods, you can express connections of those methods to the outside world, in particular to the runtime container. The constructor here, my book admin service, takes an account repository, so just a repository object that it probably needs to use somewhere else later on in its implementation, and it wants to receive that external repository reference here through constructor injection, through dependency injection at the constructor level. The add-auto-wired annotation on the constructor here is just basically a hint to the container saying, dear container, if there's no more specific metadata, please use this constructor here to construct an instance of my book admin service class. The container will then resolve all the parameters. It will find out that you declared an account repository. It will find a matching account repository bean instance or bean definition in the container and inject it for you. It's not just about the container hint, though. It's also about the expressiveness in the source code. You can basically read those characteristics here. You can, for example, say, this constructor here is auto-wired. It will be automatically wired at runtime. Because you may have other constructors, maybe for testing purposes, that you are only calling directly through manual construction in some of your test cases. So these annotations here are also additions to the descriptiveness of your source code. They basically support the readability of your source code. The third kind of annotation down here is to be found at the update book method. It's at transactional, a declarative service annotation saying, allowing the runtime system to apply a service to this method, in this case, transactional wrapping, beginning a transaction at the entrance of that method and committing or rolling it back when we leave that method. So it's traditional transactional interception that the container will do for you at runtime. But look at it from a readability perspective. This is a transactional method. Transactional is named like that for a reason, because it reads nicely. The update book method is transactional. This is a transactional method. So again, these annotations tell you something about your source code. They allow you to express something in your source code. This is a very important part of the Spring Component Model design. Annotations are always supposed to help in the readability of your source code, and they have, as a second role, they have a connection to the runtime container where the container reacts to them. Both perspectives are important. Let's do a little bit of a deep dive on a few of those elements. Annotations are composable. Many annotations, not necessarily all, but many annotations in the Spring world are composable. Composable means that you can declare your own annotations, like in this case, a custom myService annotation that you declare in your source code. MyService is meta-annotated with a few standard Spring annotations, a few annotations that come with Spring out of the box. The meta-annotating part isn't actually rocket science at all. It's just declaring a custom annotation and applying other annotations to your custom annotation. So this myService annotation here says, as a meta-annotation, I have the role of an add service, or I inherit the role of an add service, if you will. I have a default scope session. I, by default, have a primary role. Primary has a meaning if there is more than one bean of a certain type. This type is the one is going to be injected, preferred over the others. So a characteristic that you can express at the type level usually. And it even has a default transactional rule with a custom rollback rule even. So myService as a custom annotation is basically a shortcut. It combines the characteristics of add service, default session scope, primary role, and transactional on all public methods. Through combining these characteristics into one custom annotation, all you need to do for concrete classes of yours is shown below, right? My book admin service, just a class in your codebase, can be annotated with @myService. Through annotating it with @myService, you're basically saying all of the above. My book admin service has a service role, primary role, default session scope, default transactions on all public methods. So it's basically a shortcutting model. You design a custom annotation, combine a few characteristics into one sweet, concise stereotype annotation of your own. We're calling annotations like this stereotypes in analogous to UML stereotypes. But the composability of annotations applies to all annotations, whether at the type level or whether at the method level. Most of those can be designed like this. So there's one more notion here. It's a shortcut, right? But it's not just a shortcut. It's also a choice of name. You choose the name of this custom annotation. I mean, here it's called my service. Please do not call it my service, right? Call it something meaningful in your application architecture, something that has a meaning to what you're building. Call it order service or account service, maybe just a vertical in your system, or call it service facade if it has a facade role in your system. Give it a meaningful name, because then again, this annotation can have two roles. When reading your source code, the name of your custom annotation tells you something about that piece of source code. It tells you something about what class this is. And it also combines runtime characteristics, as shown above. As a variation of composability, you can even override attributes, which is actually new in quotes in Spring Framework 4.0, has been introduced in 4.0. The overriding of attributes refers to those meta annotations. So if you take the example above, my session scoped, it's a custom annotation, just saying @mySessionScoped will inherit the characteristics of @scope session. So it's kind of a way to hard code a specific scope, avoiding the string, avoiding the repetition of that string. But there's one sweet spot in there. That custom annotation of yours has an attribute called proxy mode. And proxy mode kind of overrides the standard proxy mode attribute in @scope. Spring's @scope has a proxy mode attribute. Through redeclaring that attribute of the same name and of the same type, in your custom annotation, you allow the user of your custom annotation to override it. You can add a default, right? You can say like, the default is thanks no scope proxies here. But if you want the user of your mySessionScoped annotation to say, I want target class proxies here, he may say so through using your annotation with that specific attribute set to another value. So there's even a combination of custom annotations and specific attribute overrides, which has makes a lot of sense in some common scenarios. I particularly like the example below. My transactional is a custom transaction annotation. Again, it's called my transactional. I'm just using this as a naming principle in this presentation. Please don't call it my transactional, right? Call it @tx if you want to keep it short or whatever else. Give it a proper name. It's meta-annotated with @transactional, so it inherits the characteristics of a standard Spring transaction annotation. And @transactional has quite a few attributes. You may hard code some of those attributes into the meta annotation, like the rollback for attribute here. But you may also allow for overriding some of those attributes. @transactional in Spring has a read-only attribute. This myTransaction annotation here repeats the read-only attribute. So you allow the users of your annotation to say read-only true or read-only false, instead of hard coding it into the annotation, right? You could also hard code it and say, I have a my read-only TX annotation, which is hard coded to read-only true. That's okay as well, right? If you want it that way. But if you want it as a flag, this is a way to do it. There's a specific twist here. Notice that the read-only attribute declaration here does not declare a default. By not declaring a default, you're forcing your users to explicitly specify that flag, to explicitly specify a value. So you force your users to say read-only equals true or read-only equals false. This is actually a nice way of guiding your users. If it's particularly important for your system, for your architecture, for your design principles, to identify read-only transactions, why not force your users to say read-only true or false? If you just say read-only false by default, a lot of people are not going to set that flag, right? By not declaring a default here, you're forcing them to reason about it, to think about it, to explicitly identify whether a transaction is read-only or not. Read-only transactions, as a side note, in the Spring world has a pretty significant impact when you use, for example, Hibernate, when you use MySQL clusters. In quite a few scenarios, the read-only flag has an important runtime significance, just as a side note. Right, let's move on to configuration classes quickly. Configuration classes, you've probably seen them. They show up in many Spring sessions, examples, and guides these days. So just the general principles. In the Spring world, a configuration class is a component class, a regular component class. It's managed like any other component class in the system. It has a special role. It expresses that role through the add configuration stereotype. So it says, I'm not any kind of class, I am a configuration class. It says so through add configuration. There's quite a bit of other stuff to express at the type level, and just as an indication, you can restrict the applicability of your configuration class through a profile or through other kinds of conditions. Conditions saying this configuration class is active in a specific environment or not active in another environment. And there's a set of annotations that we call @enable annotations, allowing you to activate default container behavior through very simple means. @enable transaction management, @enable caching, @enable aspect-JSON proxy. There are many of those @enable annotations and activating standard container behavior in basically a one-line annotation expression, which you can easily do in a configuration class. You're typically going to do this on a kind of entry point configuration class, the one configuration class that rules them all, that imports all the others. Right, that's just type level annotations. The more important part in the configuration class world are the @bean methods. This is basically what configuration classes are about, a collection of @bean methods. Factory methods, essentially, each of them annotated with @bean, because in the Spring world, a bean definition is being derived from every such factory method. So instead of declaring them in XML bean elements, or instead of using component scanning, which you can of course do, right? Component scanning just identifies components in the class path and just registers them and constructs them in a standard way through construct invocations. Factory methods are a little different. They allow you to control the construction of your component. Every time the container needs a fresh instance of this bean, it's going to invoke this factory method. So whether you have to call custom factory APIs, some Fluent factory APIs maybe, or some lookup APIs, you can express all of this in a factory method and make the container aware of it through an @bean declaration. The container manages the life cycle of this instance. So the factory method is really just that, a factory method, invoked every time the container decides to create a new instance. The actual life cycle of the instance is up to the container. If it's a singleton instance, there's only going to be one in the system. If it's a request-scoped instance or a session-scoped instance like here, the container is going to identify that it needs a fresh instance for a new session. And it's going to call the factory method then. So you leave a lot of control up to the container still. But the ability to fine-tune the construction of your instance can be very important. And of course, even for standard components, you can just say, return new myBookAdmin service. If your components are easy to construct, you can still express them as factory methods. It's pretty concise still. It allows you to enumerate a lot of components. You can even connect components from one factory method to another factory method through an invocation, like shown at the bookadmin data service call here, where one factory method calls some other factory method not shown on this slide. And the container knows that you're referring to another bean then, intercepts that call, still manages the lifecycle of that target bean, and gives you a reference, the reference that you require here. So that's just a glimpse on what configuration classes can do. This is a really, really powerful model. If you want to see this in its full glory, check out Spring Boot if you haven't already. Spring Boot is really configuration classes on steroids. Spring Boot shows you what configuration classes can really do in practice. All right, a few variants that you may not be aware of. Configuration classes can inherit from base classes. Basically, just standard Java class inheritance. The base class may have some admin methods. The concrete class, myApplicationConfig, extends the base class and inherits the other admin methods that way. This is particularly nice if you want to design a kind of configuration arrangement for others, like in a framework or in a library. Even internally to a corporation, you may define like common libraries used by concrete applications in your corporation, in your environment. And this is a nice way of doing it, providing base classes. And the concrete application extends those base classes, may selectively override some of those factory methods for custom beans and preserve others. So a base class arrangement is quite nice here. As of very recently, you can also use default methods in Java 8, which is a nice twist to this. This is basically doing the same thing, but it does not extend the base class. It implements a configuration interface. This is pretty new, it's 4.2. So it implements a configuration interface. The configuration interface almost looks like a regular configuration class, but it's an interface with Java 8 default methods. Typically just default methods in this case now. And the default methods are just regular admin methods, regular factory methods. MyApplicationConfig above inherits all those admin definitions from default methods, according to standard default method inheritance rules in Java 8. So there's no special semantics here, really. It's just standard Java 8 inheritance rules. The nice twist here is you can implement more than one interface. You can design several base configuration classes designed as interfaces with default methods, and MyApplicationConfig just implements config 1, config 2, config 3, and inherits all the default methods from there. It may selectively override them, of course, in its own set of methods, but it's a nice way for multiple inheritance of factory methods. And semantically not a problem, because configuration classes in Spring typically don't rely on instance state, so it's actually a pretty clean approach. So this is a nice twist. Instead of doing inheritance, if you're in a Java 8 world, in a Java 8-based system, possibly configuration interfaces with default methods might be a way to cleanly design your configuration arrangement. Another way to connect configuration classes to each other, or to kind of get common configuration classes activated, is an import. That's actually the oldest mechanism. So add import just says, I have my application config here. I need to import that other configuration class over there. You can, of course, list a number of configuration classes that you want to import. And we're going to import them a little bit like XML imports. Just instead of enumerating the others, all you have to do is to say, I want my application config, and implicitly you get the others activated as well as independent component configuration instances. So that's actually the easiest way of doing it. And you can also import components. So that's just as a minor twist. The add import, at least as of recently, doesn't just work with other configuration classes. It now also works just with some other component classes. This is particularly nice if you want to have very minimal entry points into your system, into the configuration of your system. So it's in particular interesting if you're not using component scanning. If you're using an annotation config application context, and all you're saying is, new annotation config application context, here's my application config.class. That's all. So you start the entire Spring container just giving it one configuration class reference. And everything else comes from there. Comes in through imports, comes in through other mechanisms. If you're using component scanning, you're probably not going to use many imports at all, right? Because you identify the components in your system through a class path scan. Everything that has add configuration or add component or add service on it is going to be automatically registered. That's another way of doing it, right? Either use component scanning and cleanly arrange your class path for the components to be clearly identifiable in there, or use these mechanisms for a more explicit approach, a more explicit input approach with just one or very few configuration classes as an entry point into your system and specifying those configuration classes to get the container started. Instead of a base package, a specific configuration class. All right, last but not least, in this section, configuration classes can be ordered. So this is actually now the other way around. It's particularly important for component scanning scenarios. Because one of the problems in the component scanning world is the order of detection, the order of registration. There is no well-defined order for class path scans. There technically cannot be a well-defined order for class path scans. So if you're using class path scanning, one way of expressing a specific order of overrides in particular from one configuration class to a subsequent one is an add order annotation, Spring standard add order annotation, used in many places. Can now also be used here. Lower values go first, right? So it doesn't matter in which order you're going to detect those in the class path. My bookadmin config down here is always going to be registered first, then comes my application config, which according to Spring overriding semantics means that the my bookadmin service method up there in the my application config is always going to win. It's always going to override the other. These are overrides by name, by the way. Right? Component names have a lot of meaning in Spring still. By default, it's the method name in the configuration class admin scenario. It's the method name, it's the component name. So if you override by name here, and some people like doing this, then the order of registration is important. The last one always wins. This is one way of arranging this. Right, let's switch gears a little. Look at the injection side of things and a few twists that you can do there. And you may, I'm pretty sure you're not aware of all of them, at least. We do full generics-based injection matching as of Spring Framework 4, which means that if you have, for example, admin methods that say like my repository of account, my repository of product, we're going to fully honor the descriptiveness of that type declaration. So 2 admin methods, 2 beans in your system, one specifically declared as a my repository of account and one as a my repository of product. In another part of your system, like in my bookadmin service down here, where you request injection of a my repository, you can also say, I want a my repository of account. This is, of course, all assuming that my repository is a interface or a class with a type variable, right? For example, in the Spring Data world, this is very common. But it applies to any custom type of yours with a type variable, with one or more type variables in there. So at the injection point, you can also say my repository of account. The container is now going to do the proper match, the obvious match, right? So it's going to pick my account repository above, because only that one is a fully generic type match to my repository of account down here. In previous versions of Spring Framework 3 in particular, we were always selecting by primary type plus qualifiers. The primary type is my repository, so you would get a not unique exception with Spring 3. It would say like, sorry, this is not clear enough, a non-unique match, right? I have 2 matching beans, both are of my repository. then you would have to add a qualifier, saying like add qualifier my account down here and up there. And this is exactly what we're trying to avoid. No qualifiers necessary. In the Spring world in general, qualifiers are a niche feature. If you're doing injection in Spring's component model design, you hardly ever need to use qualifiers these days. You may choose to use qualifiers, but you don't need to. Qualifiers just allow you to select among target matches, right? If there's a non-unique match, more than one type match, you may use a qualifier to specifically select a specific match. If the primary type is not unique enough. With mechanisms like this one here, you can make the type declaration as expressive as you need it to be. And I would definitely recommend this approach. So don't use annotation metadata for things that you can express in your type declarations. This is a nice example here. Very minimal annotation usage. The actual expressiveness is in the types, in the type declarations. A nice twist in the injection space is, and we already had configuration class ordering, is also injection ordering. An injection point in Spring may require or may ask for the injection of a list of target beans. In this case, it's even using generic type matching. It's saying, I want a list of my repositories of account. So we're going to honor this as of Spring Framework 4 properly. So the container is going to look for all my repositories. It's going to select the my repositories of account. It's going to build a list with all of those my repositories of account, and it's going to inject it into your constructor. But not just that, it's even going to use a specific order if necessary. If your admin declarations above have an add order value, before we inject the list, we're going to sort it for you. So you're going to get an ordered list injected into your constructor. In this case, with my account repository Y first, and my account repository X as the second entry in the list. Also pretty expressive with minimal use of annotations only. Lazy injection points are a variant as well here. And this is actually a pretty new twist as well, as of 4.1. What you can see above works for a long, long time. Add lazy on a factory method or on a component means, if it's a singleton bean, that we're going to lazily construct it on first access. So the first time somebody requests access to that instance, that's when we're going to construct it. So add lazy on the actual declaration of the bean at the declaration point has an established meaning in the Spring world. The new part is shown below. It's the add lazy annotation here for a parameter at the injection point. So my bookadmin service here says, I want the my repository of account, but I'm okay with a lazy reference to it, because I'm not going to use it immediately. I'm just going to store the reference, probably in an instance variable, right, in a field of this class. I'm going to use it later on. And it's okay if it's not initialized yet. That's exactly what you can express through add lazy. The container is going to build a lazy initializing proxy for you, a dynamic proxy implementing the interface, and not actually triggering full construction of the target bean yet. The first time a method call comes in on that proxy, we're going to go back into the container and construct the actual target object if it hasn't been constructed before. This is a pretty important part of such an arrangement, because add lazy for a target bean above doesn't help you much if other beans in your this doesn't help you on its own if other beans in your system request the bean like this, because it's always going to be initialized pretty early. The first time somebody requests it in a constructor, that's exactly what you'll get. So add lazy for such constructor references can be pretty important for designing a lazy initialization scenario, for example, for fast startup times or other such targets. All right, switching gears again a little. We are moving to a specific part of the component model story where Spring supports a selection, quite a selection, of standard annotations coming from JavaX packages. In particular, JSR 250 and JSR 230 for the ones interested in the JCP numbers. JSR 250 is the javax.annotation package. JSR 330 is the javax.inject package. And some of it can be seen in use here. So this is my bookadmin service again, but this time not using any Spring-specific imports. So the import list above is complete, right? No hidden imports, Spring-specific imports here. We're using an @managed_bean stereotype for identifying the component. This is basically like @component or @service in Spring, just a little bit of a simpler variant coming from javax.annotation. It's not composable, but as a simple way of identifying components for a class path scan, it's good enough. Instead of @autowired, we're using @inject here. @inject comes from javax.inject, JSR 330, as a common injection annotation, and has a few nice extras to it that we are fully supporting since Spring 3.0 already. So it's pretty much a straightforward switch from @autowired. Instead of @autowired, you could just use @inject. The @inject, if you don't want to use Spring imports, for example, you can't say @lazy here. The @inject way of doing this is to inject a provider. Provider comes from javax.inject. It's a javax.inject type. And if you say, I want a provider of my repository of account, you get a kind of lazy handle to the target bean. So you get a provider with a get method, and the target bean is not going to be initialized before you call get on your provider. Similar to what we've been discussing right before with the @lazy proxy-based solution. So there are ways of doing this with @inject. And another part of this are the annotations for init and destroy methods, most importantly, destroy methods, shown here. So for a method that is to be called when your component goes out of service, there's the pre-destroy method, comes from javax.annotation. We've been supporting that since Spring 2.5 already, so for like 8 years. @predestroy identifies those callback methods. So in the Spring world, a destroy method. Also comes from javax.annotation, does not require a Spring-specific import. In Java 8, right, in a Java 8 environment, we have a nice twist to this as well. There is the optional type now in Java util, in Java 8. We are supporting this as a way to express the optional presence of a target dependency. So look at the constructor here. The constructor says @inject, so I want my parameters to be injection points. And I'm saying I have an optional reference to a my repository of account. At runtime, this means we're going to look for a reference of my repository of account. If it's there, you're going to get it wrapped in an optional handle. If it's not there, you're going to get optional empty injected. And optional has some nice API to continue from there, right? You can check for the presence or do something with it if it's present. So that's a quite nice way of expressing this. We're supporting this across the framework, by the way. You can do this in Spring MVC for optional request parameters and many other things. But we also support it for injection points. And optional of my repository of account is actually pretty readable as a Java type declaration gets, right? Again, no extra annotations, no attribute set here, just a type declaration that expresses the optionality. As a side note, if you're using Springs @autowired, you can do this as well, of course, but in Springs @autowired, there's also a required flag on the annotation. So you can say @autowired required equals false, and then you get a null handle injected. But optional is actually pretty nice as an alternative to this. Resource injection is something we've been supporting for a long time as well, since Spring 2.5. connects to the JavaX.annotation story, because resource is an annotation that comes from GSR 250, so it's even older than add-inject. And it has different semantics. If you declare a setter method as an add-resource method, we are going to resolve it for you. We're doing dependency injection for you. We're going to call that setter method with a target reference that we identify by name. So add-resource is about target bean by name. It skips all the type matching. It just says, my setter is named setProductRepository. According to Java Bean's rules, I'm the Java Bean property product repository with a lowercase p. This is the name of the target bean that I expect. So it can be used as a very efficient way to point to other beans directly, basically by naming convention. As of recently, we also support lazy injection here, by the way. So many of the features that you're seeing here can be combined. Right? You can combine add-resource-driven injection with a lazy handle. Sits on the method here in this case, because add-resource is all about methods or fields, but not about constructors. So this is the same as we've been discussing before. You will get a lazy myRepository handle here. A proxy that only initializes the target bean once actually a method call comes in for it. Right. So let's move on a little, honoring our remaining time. We have a lot of features, of course, in the web space, and in particular also towards binding. Spring MVC is pretty well known, so I'd like to focus on the binding part for a moment, because there are some interesting twists in there. This is declarative formatting at work. Spring not only has support for GSR 303 constraint validation, which is what @NotNull and @past refer to here, standard GSR 303 imports from this package here. The interesting part in Spring is the combination with other features, like declarative formatting. For example, for this local datetime here, you may assign an @datetime format to the field, suggesting a specific pattern for rendering and for parsing purposes. So if at any point in the framework there's a binding attempt to a customer instance to this last contact field through a setter or whatever else, right? As a framework managed binding attempt, the framework's going to look at those annotations. It's going to find out about the @datetime formats. It's going to use an appropriate parser and renderer, an appropriate formatter, to bind a string to that field or to render that field out to a string representation. If there is no other metadata given, you may, of course, override this at the data binder level, at the level where you're trying to render it. But if there's no extra metadata given, no external metadata given, we're going to use this information here. As of Java 8, and as indicated by the use of field types here, this is even nicer, because in Java 8 we finally get the java.time package as a sophisticated way of expressing date and time types, instead of using Java util date and Java util calendar. So the java.time package, as used here, is already pretty expressive in its types. Local datetime, local time, zoned datetime, local date are all pretty expressive types. The type itself already indicates a kind of meaningful representation, meaningful parsing and rendering as well. So you can assign @datetime format here, even with Java 8 datetime types, in particular if you have a specific pattern. But the one up here is also interesting. If you have a Java 8 local date, there is no need to add extra metadata. You could say @datetime format ISO date, but you don't have to, because ISO date is the default representation for a local date anyway. So you can just remove that line. That's why it's commented out here. Continuing the story of not adding annotations for characteristics that can be expressed in the type anyway. Use meaningful types and let the framework do the rest for you if you're happy with the defaults. Just add additional metadata if you want to deviate from the defaults, and you cannot express them in the types. If you're using Java util date, of course, then you're going to pretty much use them on all fields, these datetime format annotations. We support, just to complete the picture here, we support the same arrangement for JODA-time. Have been supporting it for a number of years already. So if you're using JODA-time on Java 6, 7, or even 8, right, the JODA-time imports just do the same thing. The classes are even named mostly the same. Just use the same types. Spring is going to apply the same default rules. You can still omit some of those annotations there. And we have a similar story for number formatting with an add number format annotation. And the add number format annotation, I'm not going to show you the simple examples, just a very recent one, can, for example, also be used with our JSR 354 support. This is new in 4.2. JSR 354 is money and currency. It basically comes with a monetary amount type to represent a monetary amount, right? A number plus a currency as a field, typically. And it comes with supporting infrastructure around, of course. It also comes with a currency unit type. What you see here is just an indication for Spring's binding support. So if Spring finds out about JSR 354, that it's present at runtime, it's going to automatically register the formatters for it. So all you need to do is this, right? You can bind straight to a monetary amount or let it be rendered out according to standard JSR 354 rules. It's going to just be rendered the standard way according to the default renderers and default parsers in JSR 354. They can be installed at a system-wide level and overridden at a system-wide level. If you want to have specific binding and rendering, well, use, for example, a Spring number format here. Spring number format, the add number format annotation, allows you to specify a pattern. The pattern can refer to currency symbols, like the initial two symbols, and it can refer to a number kind of formatting arrangement. If we encounter such an annotation, we're going to render it according to that pattern. So it's the standard JSR 354 monetary amount type, but formatted and parsed through a Spring-specific pattern. Of course, we also support binding to and from currency unit, also coming from javax.money. So this is pretty new. JSR 354 went final just a few months ago in April, May time frame. And in Spring 4.2, which is coming up for general availability in July, this is supported out of the box. Right. Another favorite example of mine of how we're dealing with those things is declarative scheduling. These are at async methods and at scheduled methods. We have been supporting them in Spring since Spring 3.0, but there are a few recent twists, a few nice twists that you can do with it. So the first example above is pretty much standard at async usage with a future return type. So the container is going to intercept the call. It's going to wrap your target method in a callable. It's going to pass it on to a thread pool that you configured centrally in your application. And so it's going to send it off for execution on some given thread pool asynchronously. And it's going to return a future handle to you, to the calling code, so that the calling code can track the execution of that target method through a future handle. In order to pass a result back, we have this little wrapper called async result that you can pass back from your method implementation. We have to do it like that because the signature says future, right? The caller wants a future. Due to Java method declaration rules, the caller has the same return type as the implementer. So we have to return something that implements future. And our way of dealing with this is async result, which is kind of just a little wrapper around the value implementing future. For the caller, of course, is going to get a real future, right? The real handle to the asynchronous execution. On Java 8, this is the first of the two Java 8 twists here, you can also decide to choose to use completable future, just through declaring it. Spring automatically reacts to the type declarations in many, many places, also here. So send email notifications, returns a completable future, and we automatically adapt to that. The caller is going to get the Java 8 completable future handle, which you can use to compose it and combine it with other completable features, for example. And from an implementation perspective, you can just return a completed future handle, because completable future has out-of-the-box support for wrapping a value. We don't need to provide our own wrapper. So you can just say completable future dot completed future, pass in the value. That's what the implementation returns. The caller is going to get a real asynchronous completable future handle. And another Java 8 twist can be found down here. This is standard at scheduled in Spring. Just assign, in this case, assigning a cron trigger to a method, asking the Spring container with a configured thread pool that you chose to execute this method, to call this method every time the trigger fires. But there's a twist here. We have two at scheduled annotations with two cron triggers. This only works that way on Java 8, of course, because only as of Java 8, annotations can be repeatable. On Java 6 or 7, you cannot repeat the same annotation type on the same method. As of Java 8, that's possible because we declared at scheduled as repeatable. So you have to follow the Java 8 conventions, but we did that for at scheduled, so you can express it like this. If you're on 6 or 7, you have to use a kind of wrapper container annotation called at schedules with nested at scheduled entries. This is much nicer. So there's quite a lot in the Spring component model overall that benefits from Java 8 features, as you may have figured in the meantime. All right, to complete this story, a little bit of Spring MVC and a little bit of messaging endpoints still to come for you. This is a Spring MVC controller, pretty much as I suppose as you know it, with at-request mapping methods called whenever a matching request comes in. We're using parameter annotations here from a design perspective again. We're using parameter annotations here to automatically extract values from the incoming request, convert them and pass them into you. Again, note how reasonably minimal the use of annotations is here. It's just at path variable here. You don't have to repeat the name. As long as you compile with the name information in your bytecode, we're going to infer the name there. So we know which variable you're pointing to, even if there's more than one. So we're trying to go the extra mile to supporting clean, readable source code, even for those endpoints. As a side note, in Java 8, this is even nicer, because in Java 8, there's a dedicated compiler flag for including parameter names. So on Java 8, if you compile with dash parameters, if you compile your source code with dash parameters, this automatically works. It also works if you compile with dash debug on Java 6 or 7. Unfortunately, it doesn't work if you're doing neither of the two, because in Java, parameter names are generally not preserved in the bytecode unless you choose to do so. For this to work, you need to choose to do so. But it's very, very nice. We're trying to do this for a purpose, not repeating yourself. To have expressive types, minimal but significant use of annotations, and no repetition. Don't repeat the parameter name or an identifier if you don't have to. Spring generally allows you to do that with some extra measures that you sometimes need to apply. Right, a side note, as of Spring 4.2, we have comprehensive course support in Spring MVC. This is what the cross-origin annotation refers to. We can't cover this in the course of this presentation, but it's a pretty nice general feature set, enabling specific controllers for cross-origin access. So just as a hint, if you want to find out more about that, we already have a pretty nice blog entry about it. Coming in 4.2, already available in the release candidates. So, last but not least, endpoints. Endpoint methods for message endpoints in particular. So, a quick rundown. Spring, as of Spring Framework 4, has extensive support for messaging endpoints. With a common messaging package, you're going to find the same style in Spring Integration, in Spring AMQP, across the portfolio. In Spring Framework Core, there are a few things you can do as well. For example, process stomp messages on a WebSocket channel. We can't go into the runtime details, but look at the design. It almost looks like a Spring MVC controller, doesn't it? Has a control annotation. Instead of request mapping, it has like message mapping and subscribe mapping to interact with the incoming message types. It uses parameter declarations. If you want to get access to the payload, just declare the payload. Like the trade object down here is just a payload in the message, automatically converted into a trade object for you. And you can bind to certain destination paths in Stomp through specifying the destination path here. Very similar to Spring MVC and very focused on minimal use of annotations combined with expressive types again. As of Spring Framework 4.1 and refined to some degree in 4.2, we also support a similar style for GMS listeners. So if you look at the example above, if you have active @enable GMS support, then you can do stuff like this. Declare a method with an incoming message payload and an outgoing message returned from it, and an innocent-looking GMS listener annotation with a destination assigned. We're turning that into a message listener whenever a corresponding message comes in. We're taking that message, extracting a payload, converting it to an order. We call your listener method here. If the listener method returns an object, like here, the order status, we're going to turn this back into a message, and we're going to send it on the suggested reply destination. You can specify a response destination explicitly, but we're going to take the reply to destination by default. So again, from a design perspective, very similar to what you've seen before, applied to the GMS domain. GMS is pretty complex in its setup, so you can see a second variant of this where a lot of metadata is specified. So if you need to be more specific in your GMS bindings, our GMS listener annotation lets you do it, but if you can get away with the simpler variant, of course, please try to. Right, and we're also doing something very similar with event listeners as of 4.2. Shouldn't come as a surprise at this point. It's an @EventListener annotation, an incoming object, Spring application events typically. You can receive them as an application event handle in Spring with some extra metadata, or you can receive them as a payload that we extract from the event, very similar to the GMS listener way of doing it. You can even assign conditions that we check before we invoke your method. You can kind of filter out which events you want to receive. Most important part, the design perspective here and the consistency of the design with other endpoint models in Spring. And this is new in 4.2. All right, so since we have 1.5 minutes left, that just about works. We have the same kind of story also for caching annotations. This is Spring's use of caching annotations here. @cache config at the type level, @cacheable to identify cacheable methods, and a couple of special variants for putting and evicting. The same kind of model, you get interception at runtime and so forth, but from a design perspective, very readable source code. Look at the @cacheable signature. The @cacheable on that method tells you something about that method. It's a cacheable method. It even doesn't have to be cached, it's cacheable, because you can deactivate caching and it still works, right? And as of 4.1, you can do the same with the GSR 107 cache annotations. So kind of also completing our standard annotation support story. GSR 107, released last year and supported as of Spring 4.1, has very similar annotations inside, which you can use as a direct replacement of Spring's caching annotations, if you choose to do so. All right, this is basically it. This is just a bonus slide. You may be aware that you can use Lambdas with a lot of Spring callback APIs. Everything I've been saying was about the component model. This is not strictly about the component model, but of course about the implementation of your methods. Please use Lambdas if you're on Java 8. In particular, with a lot of the Spring APIs like JDBC templates shown here, it's a very nice combination with the component model features that I've been talking about before. So this, of course, works for a few years already, but now is the time, if you're on Java 8, consider aggressive use of Lambdas with the Spring APIs. All right. So much for it. You are aware of boot anyway, so I'm just going to skip this at this point if you've been to yesterday's sessions. Just repeating that Spring Framework 4.2 goes generally available in July. We're currently preparing the second release candidate. It's going to be released later this week, in all likelihood. So Spring Framework 4.2 is just around the corner. If you'd like to hear a little bit more about the Spring Framework roadmap, so beyond the state of the art that I've been covering here, I have a 15-minute quickie session at lunchtime, I think at 1 o'clock today, where I'll be giving a bit of a preview for the next 12 to 18 months of what we intend to work on. It's kind of a nice continuation of this presentation. All right. Well, thanks for your attention. I hope there's been something interesting in there for all of you. And enjoy using this stuff in practice. Most of it is available already in 4.2, comes your way in July. It's going to be immediately supported from our side in production as of July. So you can start using it now, basically. So thank you, and enjoy the rest of the conference.